Just putting your patient on a cardiac monitor and seeing this feel very intimidating. Wanting to try to understand more of what these squiggly lines mean? Well, you came to the right video. All right. So, um, in discussing some very kind of basic EKG stuff, I noticed on TikTok there have been a bunch of requests as far as stuff that EMTs would like to know. Um, just sometimes a little bit more with like what they're looking at if they have a patient on a cardiac monitor, when they should put a patient on a cardiac monitor, when they would need to elevate from a BLS to an ALS intercept or request ALS be on standby with them for a particular patient based upon what they're seeing on the monitor. That and just to hopefully kind of understand, stuff beyond just a bunch of squiggly lines. Everything that I go over here is going to be very, very basic. So if you would like a more in-depth type of thing, I have no problem whatsoever doing that. Just please let me know down in the comment section, whether that be on here or through TikTok. But yeah, just to go ahead and kind of get started. So basically, whenever we have a patient on a cardiac monitor, we put their leads on, preferably on the limbs, if possible. Um, I know some people have disagreements with that because people's arms and legs and everything move around. It can give a lot of artifact, but they are called limb leans for a reason. Um, and so, you have your white one that will go on your upper right side, either on the arm, shoulder, or on the upper right chest. Um, you have your black one that goes on the upper left side, whether it be the upper shoulder, upper arm, or upper chest. The red one that goes down below the black one, below like the lower abdomen on the left side or on the left leg, kind of on the upper thigh area. And then sometimes most services will have three, other ones will have four, just to kind of have as your ground lead. And with that, you would have a green one a lot of times, what color it is. And that'll usually go on the lower right abdomen or the right leg or on the upper thigh. So essentially, that is giving us a couple of different views, angle wise, from the heart. Um, but it is essentially, hopefully, generating this. So this is what you will a lot of times see on your EKG monitor, or if you print out a paper, it'll hopefully be what you see, and it hopefully won't be something catastrophically different than this. Um, so this right here is what is called a QRS complex. So essentially, what this is kind of telling us is the electrical activity that is going on in this particular view from the angle, depending upon which lead you're looking at of the heart. Um, Sometimes this will be inverted if you're looking at a particular one on a 12 lead, but I'll get to that, like I said, in a much more detailed thing if that's so requested. So, kind of the basic stuff. What is this kind of showing us? So, one easy way to kind of break this down is you have what's called this first little bump here. That is your P wave. So, what is going on there is that is telling you kind of the force and the magnitude at which the atria, which are the upper two chambers of the heart, are contracting at. So, whenever this kind of goes up, that electrical surge is your atria contracting. Um, you have this little bitty gap here that's called a PR interval. Um, Essentially, what that is in hindsight is kind of the timing between whenever your atria are contracting and when your ventricles are contracting, what's kind of coming up next. You have a valve on each side of the heart. On the right side, you have the tricuspid valve. On the left side, you have the bicuspid valve. And those are kind of opening and closing kind of within this time frame here. And then right here in this little dip, going into this big surge here, you have your QRS complex. So you have your Q wave, your R wave, and your S wave. This right here And this bracket here is essentially where your ventricles are contracting. It's why a lot of times it's a lot higher of a magnitude, because your ventricles are putting out a lot more power than what your atria normally are. And also, kind of within this, it's giving you a lot of times what people use to generate their heartbeat. So if you're looking at a strip, a lot of times what they're doing is they're counting the amount of R waves within a 6 or a 10-second strip to generate a patient's heart rate. And then over here, you have your T wave. And this is essentially representing your ventricles, what's called repolarizing or relaxing. So a lot of terms that you'll hear sometimes is repolarizing, depolarizing. And essentially, so whenever your atria or your ventricles are depolarizing, they are contracting. They're changing their current from being a positive current to a negative current. Whenever they are repolarizing, they are essentially kind of gearing back up to have another contraction, but they've got to kind of almost inflate a little bit, if that makes sense. They're gonna have to fill back up, and so the repolarizing of your ventricles is what's being shown in your T wave. Now, a lot of people say, okay, so my atria is contracting, my ventricles are contracting, my ventricles are relaxing. When does my atria relax? So the atria actually are, relaxing within this QRS complex here. The only reason that a lot of times you don't see that is because the magnitude of the electrical activity that's being forced upon by the ventricles overpowers what you would see from your atria. So you don't have any part of this where you're able to see your atria kind of relaxing and kind of starting to fill back up before they contract again. So a lot of times a normal kind of nice little hump here, an interval here of anywhere between 1 to 0.2 seconds is considered normal. This interval within here, anywhere from 0.8 to 0.12 seconds is considered normal. And those are just some kind of things that we're wanting to make sure to look for, because if this is elongated or it's shortened, we're trying to figure out why that is on an advanced cardiology type of level. A couple of reasons why to put a patient on a cardiac monitor to see kind of what's going on. Obviously, if you have somebody that is, very excited, especially those if they're complaining about any pain, chest pain, most sincerely, you want to get them on this and start your chest pain protocols, whether that be in some areas, starting to give your patient aspirin, starting to give your patient nitroglycerin if their blood pressure is able to tolerate it, and then kind of starting to run a 12 lead to get a lot more different angles and a lot more different views of the heart. Some things to kind of be wary of whenever you have a patient on a cardiac monitor. So the normal kind of rate for somebody is anywhere between 60 and 100 beats per minute. That is considered the normal. So essentially, whenever you're looking at the monitor, within a 10-second strip, you should count 6 of these. 6-second strip, you should count 10 of them, or anywhere that would give you somewhere within that interval. Anything less than 60 is considered to be bradycardic. And anything greater than 100 is considered to be tachycardic. Tachy just meaning fast, brady just meaning slow. However, where things can kind of get a little bit weird or interesting is just because someone has a heart rate of, say, 54 or 56 resting doesn't mean that they're in dire need of immediate help. Some people athletes are the ones that mainly first come to my mind with this, will walk around with a lower than average resting heart rate a lot of times at rest. That's kind of the key phrase there. I know of several people that I went to school with, and their resting heart rates were anywhere between the high 40s to low 50s. They were completely fine. Now, if you find somebody that's a little bit out of shape like myself, around the 40 level, we've got a problem. Um, so, and then the same thing too um, with anybody that's got a heart rate of above 100. Um, it doesn't really necessarily necessitate immediately calling for an ALS truck, starting to freak out, starting to drive license sirens and everything. Um, the biggest thing, if I could give you any advice as an EMT that I was given and I profoundly like go upon, is a cardiac monitor is an amazing machine. A lot of times it can tell you an immense amount about what is going wrong or right with your patient. That said, it is a machine. Don't rely on this specifically to dictate your treatment or your actions. Look at your patient. And I say that because a lot of times people will put somebody on, a pulse ox, for example. Their pulse ox will be, 91, 92, and you're taught to keep everybody between 94 and 99%. So people start throwing them on oxygen. Not everybody lives in that range. You have people with like COPD, for example, that live in the low 90s, and that's their normal. So use this as it is a very great tool. Don't rely solely on this, though. Look at your patient. Ask your patient, what's going on. Look at your other vital signs like your blood pressure, your oxygen saturation. Just looking at your patient, how they're acting, what their color and everything like that is like, will tell you just as much, if not more, than what this will a lot of the times. So, as far as when do I need to call for help, or when do I need to ask for, a higher level of care, whether that be ALS or critical care paramedicine. Anytime I would say that you have a patient that is not exhibiting kind of, I know, don't go based off my 100% artwork here, but anytime you have a patient that's not exhibiting a picture like this of, you're not seeing this at all. This is all you see, and it's very widened. Like whenever you have somebody that has a rhythm such as that, or if you've got somebody that has a rhythm that is constantly just doing, this type of thing, that would be whenever I would either try to make it to the hospital as fast as possible or have an ALS intercept meet you en route, because that is something that's going to need to be dealt with very quickly before your patient rapidly deteriorates and possibly goes into cardiac arrest, for example. Aside from that, there are hundreds of different, tutorials and everything about interpreting EKGs for individuals that are, wanting to go into paramedicine or critical care medicine, or those RNs that are wanting to, understand a lot more than this is just a bunch of squiggly lines. I'm not really sure what I'm looking at here. I would have no problem relocating those of you to those videos. There's a couple in a particular group of sections that really helped me whenever I was going through paramedic school. But yeah, as far as like the basics, you've got your P wave, which is your atria. You've got your PR interval, which is your valves kind of opening, allowing that blood to get through from your atria to your ventricles. You've got your ventricles contracting within your QRS complex. A little bit of a stoppage here, and then you've got your T wave here. Another thing you might hear that's very common is whenever you hear somebody say, I've got a patient that's in ST elevation. They say that in conjunction with somebody that's having a heart attack. Essentially, kind of what that is inferring is this ST interval here being very inverted and kind of up and everything, versus it being on a nice kind of plane that everything else is running on. If this is way up here and inverted, a lot of times that's significant of somebody that's having a myocardial infarction or a heart attack. So if you've got any questions as far as what I've kind of covered here, what you would like to see me maybe go a little bit more in depth with, please feel free, like I said, to leave it in the comments section. I will be more than happy to make another video on something a little bit more in depth if you would like. But yeah, aside from that, I hope you enjoyed the video. Stay happy, stay healthy, and I'll see you in the next one. Thanks.